Hello and welcome back to the course on call flows. This is the last section of the course and is probably the most important one because here we will put together whatever we have learned so far in terms of network functions, the associated services, and the service operations all together and see how they all work in conjunction with each other to deliver 5G services. We will be covering some specific common call flows within the 5G network, and those namely are the registration, the deregistration, the service request, and the service request would be covered in two flavors. We will cover the UE requested service request or UE triggered, and then we will also cover the network triggered service request in this section. So let us start this section. The first call flow we will cover is the registration call flow. Uh, and let me get my highlighter. So registration procedure, the registration is the first procedure the UE performs after power on. Um, or in case if it is coming from say a 4G coverage to a 5G coverage. So in that case also the UE will perform a registration message. Other scenarios where registration procedure is used are the initial registration that we referred to here, power on. Uh, and then there is a periodic registration. This is kind of similar to what we had in the 4G world, which was called the tracking area update procedure. So rather than calling it a tracking area update procedure, 5G refers to it as the periodic registration procedure. And then we have the mobility registration, which is also similar to the tracking area update procedure, but this would happen, say, when you move from one tracking area to the other tracking area. So just to elaborate a little bit on this concept, so you have your network, and say you are in a tracking area indicator, which is your identifier for your tracking area one, and then you also have another tracking area indicator that is identified by two. So if a UE is here in this tracking area identifier identified by one, after a given amount of time, that timer is given by the AMF to this UE as part of the initial registration. The UE is required to periodically update and perform the registration process. And that is what is called the periodic registration process, similar to what we had the periodic tracking area update in 4G. Now, the other scenario, which can be where if this subscriber moves into a tracking area indicator identified by the value 2, here it has to perform a mobility registration uh, registration process, and it will still perform the registration process, but here the cause will be the change in the tracking area because it has moved from 1 to 2. Okay. Then the other scenario where a registration process will happen will be in case of emergency registration. This is used by the UE when it wants to use emergency services in your NG-RAN, the next generation RAN. So, as we discussed, we noted the differences and the similarities between the usage of tracking area update process and the registration process. We will review the steps in detail now for this process. This picture here shows the different steps involved in the registration process, and this gives you a overall view. And then in the next couple of slides, we will take a look at each of these sections. I have labeled them as 1, 2, 3, 4, all the way to 9. So as you can see, these look familiar. We have the user equipment, we have the radio access network, we have the access mobility function, And we can either have a new AMF, an old AMF as part of the registration process. Say in the scenario where the user is coming into a coverage which is served by the new AMF, and is no longer served by an old AMF. In that case, you will see both these entities. And we had talked about this in the services section, that we were talking about the different service operations on specific to AMF. Then we have the session management function, the policy control function, and the authorization user subscription function, and we have the unified data mediation function. So initially, when the UE sends a registration request, the radio access network selects the AMF, the access mobility function that needs to be used for processing of this registration request. Now, this can be based on a couple of key points, the AMF selection. It can be based on the requested network slice selection assistance information. So the UE, as part of registration request, will send your network slice selection assistance information, right? It will send what is called a requested. So it there is the R stands for requested, and then the RAN can use an AMF that is capable of uh, delivering the network slice that this user wants to connect to. So we saw this initially when we were looking at the network slice selection function as well. So it can so that's where the network slice selection assistance information is used by the RAN. If it has the knowledge, it can select a AMF based on that. If it does not have the knowledge, in that case, it will just send it to the default AMF, which has been configured in the RAN, and then the RAN will work with the network selection assistance function, like we had discussed before, and find the correct AMF to serve this user for this given network slice. Assuming here that the AMF is able to support the network slice assistance information, the requested one, the AMF takes the request, and then if this UE is coming in from an old AMF, it will reach out to that old AMF to get the UE context. The other old AMF will come back and send the context. So again, this is the using the service NAMF communications, which we saw, and then the service operation within this service is the UE context transfer. Right. So this is your service. This is your service operation. Then optionally, you can perform the authentication and security. And this authentication and security is again optional, because all we are really doing is we are switching from one AMF, which was the old one, to the new one. So it is optional to the network operator. So the AMF at that point, the new AMF acknowledges that it has received the context. And then at that point, there is the user connection management registration process that happens, where the new AMF registers with the UDM and informs the UDM that the new AMF is now the new AMF. At that point, the UDM pushes out all the subscriber data to this new AMF, and the AMF, the new AMF, subscribes to the UDM regarding all the changes that may happen for this subscriber related to the subscriber data management. Again, we have seen these in the services section when we were looking at um, the services offered by the unified data management. At that point, the UDM needs to send a deregistration notification to the old AMF, because the old AMF is no longer serving the subscriber. This guy acknowledges with a unsubscribe message, and then the new AMF fetches the policies from the PCF and creates the required associations using the AM policy control service again, and then the service operation is create. And then it sends a request, gets a response, and then at that point, the AMF also selects the SMF, the session management function, and uses the service PDU session and the service operation update SM context or the release SM context. And at that point, the SMF has been selected. And if everything is successful at this point, the AMF sends a registration accept and the UE sends back a registration complete. At that point, the AMF can create use the service operation create for the service UE policy control with the PCF here. And the PCF, this is again a request response. So this is the registration process at a high level, and we will look into a little more detail in the next couple of slides. So here is the step one where the UE sends the registration request to the RAN, the new radio, in case of 5G or the next generation RAN, however you want to call it. The registration requests include some key details. If temporary identities like the 5G TIMSI or the globally unique AMF identifier are included, and the RAN can map these to a valid AMF, RAN forwards the request to that AMF, else it sends to the default AMF, right? AMF selection can also be based on the network slice selection assistance information, like we had discussed in the previous slide. So just to add a little more detail, again, this is the 3GPP spec if you want to look at it in more detail. Um, but here are the mandatory attributes that are present in the registration request. So there is obviously the registration type. This will be dependent on either it's an initial registration, if it's a periodic registration, or a mobility, the ones that we had seen in the previous slide, or the emergency as an example. And then it will send also the mobile identity, which again can be a TIMSI or it can be a 5G GUTI. Um, so those are included here. And then you obviously have, as an example, uh, the network slice requested network slice selection assistance information can also be sent here, which is again an optional. But if it is sent, then the RAN takes that into account for the AMF selection. If this attribute is not there, then the AMF selection is purely determined by your 5G GUTI, right? So we know the 5G uh, GUTI is composed of your set of AMF identifiers, right? I'm just gonna put this AMF ID, which is obviously composed of a region ID, set ID, and an AMF pointer, right? If you recall from our section, and then we have the TIMSI, right? So if the UE sends this GUTI as part of the registration request, the RAN can identify which AMF this subscriber was previously connected to, and it can send it over there. If this RAN has the connection, if it does not, then it just sends it to the default AMF, and then the default AMF can fetch the context from the old AMF. So just to kind of make it a little more clear, so we have the NR, new radio, and then say this is the AMF, right? So if this AMF ID is for a AMF that is already connected to the new radio, then the registration request is sent to this AMF. If this AMF ID does not identify the AMF that this guy is connected to, so say we had a different AMF, like this guy, and we did not have a connection here, this connection was not there. In that case, the NR would send the request to the default AMF that is configured on the new radio, and then the new AMF will reach out to the old AMF. So it's an indirect way and will fetch all the context for this given subscriber. Okay, so let's move on then. Um, So in case a new AMF is selected, the UE registers in an area where it is not served by the old AMF, and the UE provided a globally unique AMF identifier containing identity of the old AMF. The new AMF retrieves the UE context from the old AMF. So yeah, we saw that in the previous slide. And as part of this request, the new AMF will send the 5G GUTI. It will send the reason why it wants to fetch the context, and then it can also send the registration request that the UE sent to the network. So it can send that to the old AMF as well. And then in the response, so we have the AMF. So here is our new AMF, and then here is our old AMF as an example. Right? And these, we get the context request and then we get the context response, right? So this is the request and then this is the response. So the request maps to this, and then the response maps to this, right? And then the response will have your permanent identity, you will have your generic identities, you will have your GUTI, permanent equipment identifier, a bunch of DRX information, then all the subscription related information. So list of event subscriptions of by other control plane network functions that had subscribed to AMF, the old AMF. They are also passed on to the new AMF so that the new AMF can notify any network functions that had subscribed for events such as IP address change, mobility for this given user. So let's move on. Then the authentication process is carried out as we described before, right? So again, this is optional. So it may or may not happen. In case a new AMF is selected, it lets the old AMF know that it is taking over. So that is where this process happens, where the once the context has been exchanged, the new AMF sends a notification to the old AMF that hey, I'm serving this new subscriber. That's why you can clear all your contexts for that subscriber. So 4 is this guy, and then in 5, the new AMF registers as the serving AMF for the UE in the specific access technology using the UE connection management service that we had looked at in the past there, right? So this is where this step happens. It also gets the subscription data from the UDM, and it subscribes to the updates if they are if any of the subscription data changes. The UDM is going to notify the AMF about those changes. Okay, and then the UDM notifies the old AMF that it is deregistered in the UDM because the user has moved into a new AMF. So that is where the unsubscribe service is used. So then some of the other remaining, in case the access and mobility policies are deployed, AMF initiates establishment of the AMF policy association with the PCF. So this is in step 6, where this guy is able to uh, get all the policies for this subscriber, and then the AMF is able to get those policies from the UDM when it was getting all the subscription data, and in this step, it is creating an association with the PCF for this given subscriber. Again, this is optional, so if your PCF is deployed, you will do this. If not, it won't. And then if the UE had indicated that it wants active user plane connection for any existing PDU, AMF invokes the PDU session update function update SM context service operation for those sessions. So typically, when you are doing a registration message procedure to the network, you can either be doing it due to mobile originated signaling, or it can be mobile originated data, right? Or it can be mobile terminated, correct? So if it is mobile originated data, the UE identifies in the registration request all the PDU session IDs for which it really wants to uh, do data traffic. So this is what is sent here in the PDU session ID, and then and that is an indication for the AMF to reach out to the SMF in step 7, telling that the user is going to actively use the following PDU session IDs. And then the SMF can interact with the UPF, the user plane function, and can make sure that those um, PDU sessions are active for the UE to use. Now, there can also be a scenario where certain PDU sessions are not available in the new, say, the new SMF. If there is a new so in this case, we are assuming the SMF is constant, but you can definitely have a scenario where your SMF is also changing. So this would be your new SMF, and then the new SMF uh, can probably not serve all the PDU session IDs that this user has requested. So in that case, the AMF actually reaches out to your old SMF, which will be this, and it tells it to release all the session management contexts for the PDU session IDs that can't be served. Okay. Um, so let's move on. Um, and then if a registration is successful thus far, then the AMF sends a registration accept message to the UE, and the UE can send a registration complete message. In case UE policies are deployed, the AMF initiates establishment of UE policy association with the PCF. This allows PCF to provide UE policies to the UE. So, if you remember, in 5G, there is the possibility where a PCF can provision policies directly into the user equipment, and this is where this service UE policy control is used, and the PCF creates this association with the AMF, and then those policies can be pushed on by the NAS protocol by the AMF to the UE. If you are interested in a lot more details around the registration process, I would recommend checking out this spec. This has a lot more information. Yeah, so that is it for the registration process. Hopefully, it makes a little more sense. The registration procedure is the first step that the UE does when it tries to access the network.